Well, good afternoon, everybody. This is Gene Bohensky at IR Thermal Systems. The title of this presentation is Choosing the Right IR Heating Method for Your Process. And in this presentation, we're going to be talking about our experience deploying infrared heating technology across a range of different processes. So let's start with a little history about IR Thermal Systems. Our company was founded in 2020 after the former management team purchased the assets and intellectual property of Radiant Energy Systems and Anderson Thermal Devices. And so our management team and employee experience dates from 1985, even though we were founded in 2020. We are equipped to service and maintain any of the heaters that were sold by Radiant Energy Systems and any of the devices sold by Anderson Thermal in the past. Our core competence as an organization is the design and manufacture of custom engineered process heating solutions for improving performance and lowering production costs. Our focus is always on quality and dependability of the equipment. We constantly invest in the latest manufacturing technology, and we produce our own high-quality component parts. We're focused primarily on continuous heating processes. That means that product is continuously goes through the process and is heated as it moves through the oven. We are also technology independent. That allows us the freedom to choose the best technology for the customer's application, and we'll talk a little bit more of that in our presentation. So we basically are a custom manufacturer. We make custom products for our customers' application requirements. And most of them revolve around preheating, drying, and curing applications. We produce hot air systems, infrared systems and heaters, and combination hybrid IR and hot air systems, where the IR is sometimes referred to as a booster. So what we try to focus on is to increase line speeds, to reduce energy costs, to save space. We level out uneven temperature or moisture across a web. And we can also heat selected zones across the web. And really our focus is on solving application challenges that our customers have. Well, our team has many years of experience doing this, and it's one of the strengths of our company. So we serve a wide range of industries, certainly the converting industry, paper, film, and foil, paint, printing, nonwovens, plastic, adhesive lamination, batteries, which is a big topic today with the increased focus on battery-powered just about everything, medical devices, filter media, fiberglass, advanced composites, industrial fabrics, automotive applications, packaging, wire and cable, textiles, and many others. So how we work with your team, we have our own process where we have specialized engineers review your existing process information. Together, we determine the best technology to use to fit your goals. With state-of-the-art design tools, we develop a system tailored to meet your target specifications. And we also offer a low-cost infrared rental program that allows you to try our technology in your plant. We'll talk a little bit more about that because many of our customers are unfamiliar with infrared heating, or they're just deploying it for the first time, or they're adding it to an existing process to solve a problem, either to get more productivity out of the process or to solve some application problem along in the heater. So we have project specification sheets. We have a wide variety of them depending on the application. And we typically ask our customers to fill this out so that we can begin the conversation with some intelligence, understanding some of the issues that you have. So there's basically three major applications that we look at. The first is drying. That's solvent vaporization or evaporation from the web, from the product. There's also curing with a final web and coating temperature requirement. normally following a drying requirement, that really applies to modern paints and powder coating. There's this also heating applications where we're raising the temperature of a product, either for heat set, for heat before lamination, or 100% solids applications, silicon coating, etc., and foils. And also for metals, that's another application. So why should you choose infrared heating? So in general, this is some general statements. Infrared heating systems are more efficient with lower energy requirements for the same results. So energy costs can be significant. More companies are installing this technology to be more green, especially today as energy costs continue to rise and we see some of the challenges in other countries. Those differences in energy costs become more pronounced when looking at heaters. With infrared, energy is directly transferred from the heater to the target object for a higher heat transfer rate, and they are available in either electric or gas powered. So some general characteristics. For infrared heaters are generally easy to zone for uniform heating of the product and for width changes. They're well known for fast response to changing process conditions, including quick startup and shutdown in most styles of heaters, and fast temperature adjustment. Lower initial capital and installation costs, including floor space savings. And they're often added to existing conventional dryers to increase line speed and improve process quality. Basically, there's a range of different types of infrared heaters based upon their wavelengths. We see that wavelengths used for industrial heating applications range from 1.17 micron, that's roughly 4,000 degrees Fahrenheit, to 5.4 micron, 500 degrees Fahrenheit, where the wavelength is directly related to the temperature. You can see those that graph on the right. So short wave emitters range from 2150 Fahrenheit to 4000 Fahrenheit, and those are typically done with lamps. Medium wave emitters are 900 degrees Fahrenheit to 2150. We make a lot of those emitters, and those are usually metal. There's also long wave emitters, 500 to 900 degrees Fahrenheit, and we don't really play too much in that marketplace. So you choose the wavelength based upon the application. This is a big thing. So you could see here, you have some absorption curves for different materials. There's water film thickness at 10 micron on the left and PVC sheet thickness at 1 millimeter, depending on what you want to go after. So if you want to heat up the water, you have a different wavelength that you're choosing than if you're heating up PVC. So we're going to start a short video with Cornell and IR Thermal demonstrating medium wave dryers, a medium wave heating here. I'm going to start this right now.
Today we're demonstrating our medium wave infrared heater. This heater is used for typically for heating webs, heating plastics. It is in the 3 to 8 micron range. That is an ideal range for absorbing water. We make everything here. This heater, we make the elements, we pin them on the boards. Some boards have holes in them for airflow through the heater to aid in the heating process and break up the vapor barrier. These heaters can be sold individually to our customers or incorporated into an oven system, complete with framework, doors, controls. They can be controlled by thermocouples internally in the heater or by infrared thermometers measuring the temperature of the material moving under the heater. Generally, these are 2 to 3 inches away from the product, which can be horizontal or vertical, any direction. They are known for fast heat up and cool down. And we'll demonstrate real quickly. If you could please turn on the heaters. We're going to bring this up to full power. Usually it takes less than a minute. It depends on the element we use. The thicker elements are a little slower. Thinner elements are a little faster. This particular unit is a rental unit that we can send to our customers to try on their own line. As you can see, the elements are similar to the elements on your toaster oven. It's the same wavelength, but if you shut it off now, you'll see how quickly it cools down. And in addition to that, if we had air blowing on it, we could increase the velocity of the air to help in cooling down the material underneath the heater so that it doesn't get damaged.
So next up is a demonstration of our short wave dryers and heaters, and you can see in this one you have the lamps instead of those metal elements that are used, and this gets a lot brighter. So you can see from here, you can see that the heat is a lot hotter and a lot more intense. So let's get that started.
Now we're going to demonstrate the shortwave infrared heater. It's in the 1.5 to 3 micron range. It's a quite intense heat in a small package. This particular unit has some air holes for aiding in the heating process, breaking up a vapor barrier. And the lamp itself is made of tungsten inside with a gas that's in a sealed quartz tube. These elements can get up to 3,500 degrees versus 1,800 degrees on the medium wave. So now we'll go ahead and turn it up, and we'll bring it up slowly because it does have a high inrush. So if you're using an SCR like we are, you want to make sure you have a little bit of a delay so that you don't blow fuses. So we use high-speed fuses on the SCRs to protect them. So here you can see it's in the just maybe a quarter of the way, halfway, and it will get very intense, the heat. It is okay to look near it, at it, but not directly at it, just like you wouldn't look at the sun. It's not as hazardous as UV lamps are. UV lamps you don't want to look at all. You can look at these. Best not to look at them for an extended amount of time. Shut that off now. As you can see, it's an intense amount of heat in a very small area. Quick heat up and cool down. Thing about these is you can't control them with the thermocouple internal because the lamps are sealed. The best way to do it is with an infrared thermometer measuring the temperature of the material being heated. Now we're going.
Okay. Let's now that you've seen the way those heaters work, let's talk a little bit about the different applications that infrared heaters are used on. So typically they're used for industrial drying powder coating and paints, for other types of coating, annealing, filter media, nanofilms, battery, and fuel cell materials. Especially there's more and more painting using powder coating, as for environmental reasons, you want to get rid of the solvents. So additionally, as solvent chemistries become more complex, infrared heating becomes required due to faster response time and better control of temperature, because with infrared, you can really dial in that temperature that you want the web to have. Also, plastic for embossing. Medium wave infrared directly heats and softens the surface quickly. Water-based coating on film. Medium wave infrared directly heats the surface and is the most efficient wavelength for water evaporation. And it can be used with or without air. So air removes the steam and prevents the skinning effect. It improves efficiency of infrared to remove volume solvents. That is, having additional air or blowing across the web while it is being heated with the infrared heating. So they're also used for adhesives, impregnated fiberglass, and many food applications like baking of cookies, and other products. To improve the paint quality, new coating methods require consistent high heat for proper curing. Metal processing, IR emitters can be precisely adjusted to the product in the process. So medium wave IR dries faster on the surface, while short wave IR tends to penetrate deeper. High gloss metals reflect very strongly, while dark surfaces absorb heat well, and each metal absorbs heat differently. So that's another reason for the adjustability. Flat sheets or solid blocks heat up at different rates. And in general, it improves the energy efficacy of drying applications. So there's a little slide about gas versus electric infrared heaters. Electric heaters have a wide temperature range, better turned down, with infinite temperature control and tunability. Usually the watts per square inch is about 50 to 55. With gas infrared heat, you have a higher density of heat that allows higher temperatures and high intensity heat in a small package. So up to 50,000 BTU per square foot, or roughly 60 to 100 watts per square inch. Again, the gas is more intensive medium wave heating. The choice of gas or electric might be made by local energy costs, and we've seen that a number of times, and is often used to cure powder coatings on any substrate. And we've actually done some applications where there's been a combination of gas and electric. The electric where you wanted to control the heat a little bit finer. But there's the two different style emitters. This picture on the left is the electric, and the picture on the right is the gas. So if you're not familiar with IR heating and you want to get to know how to use it, something we suggest that is essential to run trials in your lab or on a pilot line to confirm dryer sizing and desired finished product. Some coatings may not be able to take advantage of the higher rates of heat transfer, and they might skin and blister, and you want to test that in advance. It may be difficult to work with temperature sensitive substrates. Since infrared is basically a surface phenomenon, sometimes it's harder to dry heavier coatings without overheating the surface. Again, our rental program allows customers to deploy infrared at a low cost to learn. And again, we suggest that if you're not familiar with it, get in contact with us and we can supply some systems for you to test with. So let's look at some pictures. Here's a shortwave infrared for drying coatings on metal webs. There's a multi-zone IR system for automotive interiors. There's a multi-zone IR preheater for embossing wall coverings that we've made. Here's a high-intensity IR gloss recovery system for film. You can see the lamps on the top there. Is an IR oven laminating web to web using film, powder, or other adhesives. And one of the things we'll specialize in is in combination hybrid dryers, where we use the standard dryers with a hybrid. You can see on the right there, we have a combo dryer element. We specialize in this, and that's something that we look to work with the customer to make sure we meet their application requirements and solve their process problems. And they can be either combination convection and infrared or combination electric and gas infrared. And oftentimes we see the infrared section used as a booster to existing processes. It allows for a faster warm-up of the web in the process. So if you have a really long heater, you can really cut down that length of the heater that is required to get the web up to the right temperature. It's used to increase the line speed of existing processes. And if you're faced with having to increase production, but you don't have the space or the investment for all new equipment, then this is a very easy way to do that. We expand production capacity of existing equipment in the same footprint, and we can improve overall process temperature consistency. And we've also used the additional infrared heating to solve specific customer quality problems. And there's two that I just want to mention in this presentation. One was with the plastic bottle annealing process. What we did is strategically place IR heaters in the, in the line to eliminate cracks during bottle handling. That was able to solve a process problem. Another one was preheating heavy commercial vinyl wallpaper. IR heaters were added to evenly heat the paper across the entire surface, greatly improving embossing quality. Those are some of the application challenges that our customers come to us with. We have the expertise to solve those problems and also the products. So if you have any of these issues at your own facility, you might want to ask us a question at the end of the presentation. And here are some large combination dryers, some pictures of things we made in the past. This is a combo hot air impingement and infrared air dryer. It's a 24-foot long dryer for drying and curing coatings on nonwovens. Here's another one where it's a combination drying a water-based PSA on PE film. And last but not least, I want to talk about our rental heater program. So our heaters are available in widths from 12 to 84 inches. They're available in 240, 480 volts, 1 or 3 phase. Our packages include the heater, blower, and control panel, designed for quick trial setup. Plug and play rental terms as short as 1 week are available, and test units are available for running trials in your facility or on your line. So we've come to the end of the presentation. Now is the time for your questions. So we have one question. We have Cornell, our technical specialist, in the room, as well as Al Foss. And they're here to answer any of your technical questions regarding heating. The first one that was presented in the chat is, can you heat concentric stainless steel tubes of lengths 6 to 12 feet to 900 degrees?
Well, I don't have enough information for the application, but it certainly sounds like something we can do. The difficulty in heating steel is how reflective the steel is. So the more reflective it is, the less it will absorb the infrared energy, and it may require a lot more energy in order to heat it to 900 degrees, but I think it's something that can be done. It's also a function of how long it's underneath the heaters. Is this a stationary batch type operation? Is this a continuous heating of the tube? I didn't actually see that in the chat, but if we get more information about the application, then I think that we can answer that question better. But yeah, we've done steel in the past. There was one slide with many tubes. It was a large panel of shortwave lamps that was used to continuously heat a sheet of steel that had a passivation coating on it. And we were able to successfully do that. That application was for a large steel mill in China. I hope that answered the question.
It's a continuous process. The tubes are 4 to 6 inches ID.
Yeah, I see no reason why we couldn't do that.
Okay, maybe if you want to send us, just put your email in here. We'll get with you and talk a little bit more about that application with you.
Mm-hmm.
Here's the next question. Can you use IR heaters to bring carbon fiber PEEK laminates to melt before forming them? And what type or wavelength would you recommend?
This is something that we would want to see a sample of to run in our lab to check it. Usually we've done this in the past with medium wave. Carbon fiber, I would need to know the temperature that you need to melt, to melt that. It depends on how thick it is. And again, the residence time under the heater. It is something we can do. Some considerations when working with carbon fiber are the carbon dust that may be in the air needs to be minimized because it can get on the elements and it's conductive. So that's a consideration. So lamps might be a good choice for that rather than the exposed elements that you saw on the slides. So we have done carbon fiber in the past. It's been done quite a bit in military applications. But again, best thing, talk about the application, see a sample, and we can answer that question, in more detail.
Great. Anybody else with a question? Does anyone else want to share an application that they're working with or working on, just for conversation? Do you use quartz lamps is one question.
Yes, we do. Yeah, the lamps that you saw in the pictures are quartz lamps. Those are the shortwave T3 lamps or T4 lamps. We also use medium wave lamps. They are all quartz, and we also make larger diameter, up to 10 inches, round quartz, which has the element wrapped around it for a continuous heating of a product that's passing through it. So those could be like 4 feet to 6 feet long and anywhere from 3 to 10 inches in diameter on the bigger ones. And then, of course, we use quartz on the small lamps to make those.
Yeah, I also want to point out to everybody in the presentation, we have a sister company, Anderson Thermal, which sells these lamps. We sell replacement lamps for many applications you might have. Even if you don't buy the equipment from us, we might have replacement lamps available. And we also make a wide variety of lamps available. Now, Cornell, you might want to say a few more words about that.
Yeah, a lot of our customers have lamps from other heater manufacturers and lamp manufacturers that we can cross-reference. We can usually offer those at significant savings, and a lot of these lamps are standard in the industry in the shortwave, so we can provide replacements for other manufacturers, and that's something that's an advantage that we offer is more affordable lamps. So you can contact us about that if you have some needs for replacement lamps. And then Anderson also does make small heaters. We also make the small panel heaters. So we have a wide variety of infrared heaters we can make.
And we also do assessments, right? If people have issues with their existing lamps, we could make recommendations to either provide them lamps of higher quality or improvements, correct?
Yeah, absolutely.
Okay.